It's me, Chiku from Chiku Study Corner. Today we'll be dealing with a newer chapter, that is chapter number 1 of Chemistry Class 12 CBSE. This chapter is the first chapter of the first book and it is in Physical Chemistry chapter. And this chapter has a lot of numericals and you have to do that to score high. So, this chapter is called as Solid State. So, in this chapter, we'll be dealing mainly about the first state of matter, that is solids. So, when you hear about states of matter, do you know which all are the 7 states of matter? Yes, we have dealt with them in our lower classes. So, some of the states of matter are solids, liquids, gases, plasmas, Bose-Einstein, condensate, and so on. Out of these 7, only 3 are the main, they are the very basic states of matter. Which are they are solids, liquids, and gases. So, in this chapter, we'll go in depth about what is solids and how are solids, the properties of solids, so many equations to solve, and it's a physical chemistry chapter. So let's get started. So, since we know solid is a state of matter, we have to know some of its properties. So let's discuss the properties of solids. So, before going into depth about solids, we can classify liquids and gases together as fluids. Why? Because they flow. Okay? They flow and hence they are called fluids. Substances that can flow are fluids, and gases and water or gas and liquids are something that can flow and hence called as fluids. Okay. So solids, what is the major thing, or when the word solid comes into your mind, what is the very first point that comes into your mind? That is something that is having a definite shape. Solid, it can be a flower vase, it can be a cube, it can be a glass, but anything, it has a definite shape. So the first point is solids are substances that have definite shape, mass and volume. So first one is definite shape, mass and volume. The next point is, now we know it has a definite shape. Therefore, you can say it is rigid. Why is it rigid? Because of its constituent particles. The constituent particles are fixed at its positions. Okay? Are fixed at its positions. And therefore, it is rigid. So, if they are fixed at its position, when an external force it happens to be like an external force is hitting over a solid. So how would this solid, respond to that? The constituent particles of this solid, what will it do? It will vibrate in the mean position. It will just vibrate. It cannot flow because it has a solid shape. It has a definite shape, mass and volume. So that's why it's rigid. And next, we know when we learned about solids, liquids and gases in our lower classes, we said solids are tightly packed, waters or liquids are loosely packed and gases are very loosely packed. So, let's take the condition of solids. So, I'm taking a solid. So, let's take, this is a solid. Can you see there's only very little space in between these particles? This is called as intermolecular spaces. So these intermolecular spaces are very low. So what is that? Small intermolecular spaces. And you see, even though it has a small intermolecular phase, can you see all of these particles, the constant particles, are bound together? Yeah? The binding force is called as intermolecular force. Can you see the binding is so strong that there is no space in between? If the binding was weak, what would have happened? The constant particles would have moved around. Since the binding is very strong, what can you write? It has a very strong intermolecular force. So what? Strong intermolecular force. Okay? These are the basic or general properties of solids. Now, to talk about solids, solids are classified into two. Okay, let's see what is that and what all are the points that come under the classification of this. So as I told, what? Solids are classified into two types, that is crystalline solids, and the next one is amorphous solids. So, how is this classified? How is it classified? On what basis is it classified? It is classified on the basis of the arrangement of the constituent particles. So, let's take for crystalline solids and amorphous solids. Crystalline solids are what you say, they are pure solids or true solids, whereas amorphous solids are not actually what you say solids, but they are pseudo solids or false solids. So, what is this? Crystalline solids are true solids and amorphous solids are pseudo solids. Okay. So, how can you divide or classify this on the basis of the arrangement? So, let's take a solid and let's take it has two particles, something that looks like this and the other one will look like this. Okay, this is the particle. So, in this, there are two solids. Okay, we are taking two solids. So, that we can compare and tell which is crystalline, which is amorphous. So, I am taking the two solids and I am marking this to be like this. Okay. And over here, this is. Let's take the bigger particles. There is two constituent particles. No. So, this is the bigger constituent particle. So, over here what can you see? That here there is a regular pattern or there is a particular arrangement. Okay? There is a particular arrangement. And over here what is this? This is just random arrangement. It's not in a particular order. It's not an orderly arrangement. Whereas in this case it's an orderly arrangement. The orderly arranged particles or the solids having constituent particles that are orderly arranged are called as crystalline solids. And the ones which are not having an orderly arranged constituent particles, they are known as amorphous solids. Okay? I hope this is clear to you. So, a better example, in a school, okay, the students are let out in a ground to play. When they move out and they just play, okay, in the ground. There's some group of girls, group of boys, teachers, schoolmates, everyone are there, bus drivers, helpers, everyone are there on the ground. And they are all in their own business or they are enjoying the game. So, now the school principal gives an announcement that you have to stand in attention in the position where you are. So when they stand, they would be randomly scattered because some are playing, some are talking, some are writing notes on the ground, or some are going on like doing something else other than these all. So they are in different positions and they are scattered. And that kind of arrangement is something very similar that you can see in amorphous solids. Okay? And whereas in crystalline solids, when you are taken out for, let's say, an assembly, a school assembly, you will be standing in an orderly pattern. You will be like 10A, 10B, 10C, 10D, 10E. You go in the same order in straight line patterns. So that is an orderly arrangement. So when you are at your assembly, you act as a crystalline solid, and when you are out free without no rules and regulations, then you act as amorphous solids. I hope this is clear to you. So now let's see more about what is crystalline solids and amorphous solids. So for crystalline solids and amorphous solids, now we're going to learn a new term, that is anisotropy. So let's see what's anisotropy. Anisotropy. So there are two types of anisotropy. Let's see which one is crystalline solids anisotropic or is amorphous solids anisotropic. So let's see. Anisotropic and isotropic. So when you hear that, usually when people classify these, they will write as crystalline solids under isotropy and amorphous under what? Anisotropy. But actually it is wrong. Crystalline solids are anisotropic, and whereas amorphous solids are isotropic. So let's say what is this anisotropy and isotropy. So let's take a solid. This is a crystalline solid. This is an amorphous solid. So let's draw the amorphous solid and crystalline solid fast. Okay, and over here let's draw 1, 2. This is a crystalline solid. Okay, so let's take, if you take an entity, a quantity, for example refractive index, if you measure it in any direction, if you would get the same value, will you get the same value for crystalline solid? This is crystalline, this is amorphous. So let's take, I'm measuring it from this side. Can you see that over here there is more blue, that is the constant particle which is represented in blue is more on this side, and if I take, like I'm measuring it like this, so what is this? The values are different. When you measure it from every direction, the values are different because of what? The different arrangements, or they have an orderly arrangement. See, now if I have to measure in this manner, see here there is more, here there is less. So there is difference in what? The arrangement. Okay, or when you get a value for the refractive index when measured in different directions, then it is called as an isotropic, okay. Whereas if, now let's take this case, if I draw like this, 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 anyway, however you draw, you will get what answers having almost similar solutions, because what? That is because there is no particular arrangement as such, almost same number in both the sides. Okay, it's almost same number in both the sides. So I think this might be a bit confusing. For better understanding, let's take the situation that we took before itself, that is a school or a group of children or a school. Okay, the children of that school is allowed to move into a ground and they are playing. Suddenly the principal says attention, and everyone stands still in their position, and out of them 3 children are asked to move out, and these 3 children has to move from one end to the other end. The 3 people are standing like this, so this person has to go to the other end, this person has to go to this end, this person has to go to this end. So they have to what? Go without hitting or hurting the other person. So all the 3 has to take the same effort and concentration to move to the side, because it's not an orderly arrangement. You have to go like this, no? In the same way, if this happens in an assembly, you're taken down to an assembly and you all are standing in straight lines. When you do that, what happens? And you ask 3 children to move out and stand on different corners and ask to move out. So the one between the 2 lines would have an easier task. You will stand like this. If the person has to move from here to here, then what? He can move between the gap. But whereas the person is standing over here and he has to go between these children. So he has to move like this and go. So what is that? There is a difference, okay? Like when you are in assembly, if you are between the lines, you can go easily. Or let's take the same example. This is our group of students standing in line, okay? If one student from here has to cross to the opposite side, it can go like this. Am I right? But one child who is standing over here, if he has to cross, he has to move like this, he has to move like this, he has to move like this, and then get out. Am I right? Yes. So they should move in a linear pattern. He has to reach the opposite end and reach this point itself. That is the straight line opposite to it. So you can't measure anything like this. Do you measure any values in a curved manner? Whatever you measure is always in straight lines. Okay? So what is isotropy and what is anisotropy? That is when measured in different directions. If you get a constant value, it is known as isotropic. And what are amorphous solids are isotropic, whereas what are crystalline solids are anisotropic. Okay. Next one is to talk about the melting point of these. Let's take, this is a crystalline solid, okay? And this is a amorphous solid. Okay. Let's take, in this case, if you have to melt something, okay, if you have to melt this compound, what should you do? You can give equal heat because it's arranged in a particular order. It's all in a particular order, therefore it has a sharp melting point. Okay? Sharp melting point. A sharp, yeah, because why do you say it's a sharp melting point? Because all these constituents are arranged, and if the temperature is given in a particular range or in a particular amount, all of this would get melted. Whereas in this case, let's see, I give heat. Okay, if this has to melt, the melting point of this constituent atom, here there is more density of these atoms, here there is only less density. See, this way you have to give different heats to different parts of that compound to get it melted. So therefore, what can you say? There is no sharp melting point. You cannot say that, for example, glass melts at 200 degrees Celsius. But no, you can say glass melts from 200 to 250 degrees Celsius. So it gives a range. It's a range of temperatures. Range of temperature. Whereas for ice, what can you say? Ice melts at 0 degrees Celsius. If it is 0 degrees Celsius, the ice would, ice would melt at, 0 degrees Celsius, it will become ice, and 100 degrees Celsius, it will get boiled. You can say a particular given sharp temperatures. Am I right? So next point is to talk about the cleavage. To talk about the cleavage property, let's see. So both in what are amorphous and crystalline. So what do you mean by the cleavage property? Cleavage means cutting or breaking. That is known as cleavage. So what is the cleavage property? Let's see the two cases of amorphous solids and crystalline solids. Amorphous solids have a smooth cleavage. That is, if you break a glass, an example for an amorphous solid is glass. If you break a glass, you will get a smooth surface. If you break an ice, you will have a uneven surface. So, what is that? The cleavage property, it is a smooth cleavage property for amorphous solids, whereas for crystalline solids, it's not a smooth cleavage property. So, the next one is that amorphous solids doesn't have a fixed shape or definite shape, whereas what crystalline solids have a definite shape. Okay, So examples of these are, for as told, it's glass, and over here it's ice. Then to talk about the fusion, the latent heat or temperature fusion, let's see what is that. As told, for the temperature, the boiling point and melting point, I said sharp boiling point for crystalline solids, and it's a range, over a range of temperature for amorphous solids. The same way is the fusion. It has a particular temperature, a heat of fusion is a definite value, whereas for amorphous solids it's not a definite value, it is a range. So that is all to talk about this amorphous solids and crystalline solid classifications. So that's all for today's session. I hope you might have understood it. If you've understood it, please give my video a huge thumbs up and also subscribe to my channel if you're new to it. And share my videos with your other friends. So see you on the next part of this chapter. Till then, bye.